So today we're continuing with the PA systems. I was going to have just 2 sessions on that, but the time allows us to go over some things in a little bit more detail, which is to our advantage, which is good. All right. I just oh yeah, right off the bat, there are still some questions rolling in the email about the lab. This week until Friday, there are no labs in person. All right, the lab that you're supposed to do is on your own, using the instructions provided, and the instructions are in the YouTube channel on our YouTube playlist, and you can find that YouTube playlist right here. See, here's our class portal, and the announcements are automatically displayed. So just scroll down the announcements until you find our YouTube playlist, and you can either click on that, or what I'm going to do right now for change, copy that link, and I can just call up another window, paste that in the address bar, and voila, there we have the I didn't know I spoke French. We have our YouTube playlist being populated as the lectures go on. All right, so here is the video on how to prepare the deliverables. Here is the video on the navigation to the submission box. And here is the video from last year. If you go to an hour and 15 minutes mark, you are going to find the instructions on how to properly fill out the work order, which is our lab report. And also, right here, again, our class portal. You go to content. I'm just explaining that because I still get emails. Once you go to content, you go to your, you know what? Here, let me make myself look like a student to the FOL. So I'm going to show you what you're going to see. Here is your class portal of this course. And if you go to content, click, you're going to see student items. And there are lecture, post-it notes, and labs. Here is lab 1. Click on that. And here are the instructions of exactly what to do for lab 1. Plus put it together against the video instructions, so you have all the information that you need for that. Also, you're going to find in the content blank work orders for labs. That's what I titled that. And this is the work order. I just clicked on that. This is the work order we're going to use for most of the labs, except for one lab, which will be the coaxial cable. Okay. And you can download that, you can click on that, you can view it, and you can download this. This is the blank work order. Again, as I'm saying, just have those bunch of them printed and keep them in your binder so you can use them as you need. And just a reminder, most of our labs sessions are going to consist of 2 labs each, so you need to bring at least 2 work orders for yourself, 1 work order for each lab. Okay. All right, so let's just continue with, let me just go back to our class portal and just leave it that way there. Right. I was just searching on Google, the 1/4-inch jack as opposed to XLR jack. This is what a 1/4-inch jack looks like. All right. So over here you have tip and sleeve. This is a 1/4-inch jack because, well, the diameter of that is 1/4-inch. This here is the similar type of jack that we're using for our headphones, popularly called Headphone Jack. and it's called 1/8 jack, eighth of an inch jack, or 1/8 inch jack. So it's 1/8 of an inch. Okay? And this one has tip, ring, and sleeve. Also, so this would be unbalanced. This would carry the unbalanced signal here, because it's just a tip and a sleeve, or tip and ring. Sorry, tip and ring. And over here, there's another one, another example. Can we see that? There you go. Tip, ring, and sleeve. So that this would be able to carry a balanced signal. And go back to our previous class, previous lecture, in order to find out what the difference is between the balanced and unbalanced signal, if you haven't done so already. I'm pretty sure you have. Okay. All right, so now I call this one, well, we have in our lectures, PA Systems Part 1, PA Systems Part 2, and this is going to be PA Systems Part 2.5. Okay, it's just a continuance of whatever we left, and we just have to carry on. Now, one thing I haven't mentioned in the stage, just a typical stage setup. Now, I showed you this because any other kind of a setup is going to be a variation of this. This is the basics of a basic. This is the basic of the basics. There we go. All right. So, just as a review here, we have a mixing board, wherever all the signal processing is happening. We have every instrument and microphone plugged in, or whatever sound source plugged into each individual channel, and then the channels have controls that you're able to adjust the volume of it, of the signal coming in. You have a little bit of an EQ going on. Usually mid, highs, and lows. You do have well, you know what, we're going to go over that. So you can process each signal on each strip, and that is going to be sent to something that is called a mix. Now, a mixing board usually is able to provide more than one mix. So the signal could be routed and grouped into one sort of a signal that is going to be the derivative of all the signals that are patched into that mix. And there could be a front of the house mix. So front of the house would be the speakers that are powering the sound for the audience. It's called the front of the house. Okay? Now also there could be another mix sent. That's why we have more than one return coming into the stage box. And of course, the amplifiers are being put on the stage, and we talked about that last time. It is to provide the maximum power transfer, because the speakers have low impedance in the range of 8 ohms or 4 ohms, and the longer the cable is coming from the amplifier, the more resistance, as little as it is, but it is still going to pose some resistance in the cable. So we're just trying to have that cable that joins the amplifier to the speaker as short as possible. So that's why we put the amplifiers on the stage, and we're sending the signal to the stage box, and from the stage box to the amplifier. Okay. We had some mail coming in. All right. Now, also from the stage box, you can have another mix sent to the monitors. What are the monitors? A monitor, and here is just a little bit of an example of what a monitor. A monitor speaker is a speaker that is placed on the stage, but it's not facing the audience, it's facing the performer. And the purpose of that is to send some sort of a feedback signal, not feedback. I shouldn't be using that word when it comes to mixing audio, because feedback refers to something else. It's sending a sound reference. So if the person wants to hear themselves against all the other instruments and whatnot, that monitor mix can also be accomplished through the mixing board. Sometimes you have something that's called a split snake. So which basically, usually in analog systems, you will have a stage box right on the stage, and every channel that is being plugged into the stage box is split right at the stage box, and part of the signal or half of the signal goes to the mixing board, and it is independently mixed for and being sent to the front of the house, and other half of the signal independently gets sent to another mixing board, which usually is somewhere at the backstage or the side of the stage, and it's the monitor mix. So you can have two independent mixes, and the monitor mix doing it by a different person, and whatever that person does, it's not going to affect the front of the house, but you're going to distribute the signals for the stage monitors for the artists to have some sort of a reference of what they are doing, so they can perform properly. Okay. Now there could be also, it's a possibility in smaller venues that the front of the house mix can also send a mix channel onto the monitors. So that would be the little bit less expensive way of doing things. If anybody has an experience, or if you will have basically, if you hear this, what I'm saying right now, years from now, you're going to know exactly what I mean. But I think I'm trying to explain this thing as much as I can without actually having you to go through the experience of doing this whole thing. Now, when it comes to stage monitors, there are two kinds. Sometimes you have the stage monitors, the speakers that are being placed on the stage facing the performers, and there could be more than one, because the drummer could have a couple speakers, and there could be a separate mix for the drummer, so the drummer can hear properly different balance of different instruments. Sometimes they want to hear more vocals, sometimes they want to hear more keyboards or guitar or whatever, right? Usually the drummers like to hear the bass guitar. But the singer, the vocalist, they could have a little different mix. So there could be more than one monitor mixes that are supposed to accommodate different performers. Also, when it comes to monitoring, on the stage monitoring, quite often, more than not right now, what's being implemented is something that's called in-ear monitors. Right? So instead of speakers on the stage facing you, if you're the performer, you're going to have headphones. And sometimes when you see the performers on TV, they're wearing something looks like a hearing aid. That's basically the in-ear monitor, and the purpose of that is basically they're molded individually as the inner ear shape is. So it's done by professionals, and it's for them, right? It fits their ear properly. Then they just stick it in their ears, and the whole thing is supposed to block out everything, all the sounds that are coming in, to the best possibility. And just send the monitor mix by a crew that just does the monitor mix for the stage performers. Right? So that's another way of doing it. Right? It all comes down to how serious the event is and how much money you have to carry this thing out. Also, in addition, which doesn't seem to be here, sometimes there could be another mix. It's called a stage fill mix. Right? What a stage fill mix is usually there will be speakers on the side of the stage, pumping the sound a little bit, not too much, but just enough so the artists can get the feel of what is happening at the front of the house. Anything to make the performers more comfortable, because whatever is coming out the sound is being pumped to the front of the house. They don't have, they just hear some noise. They don't have a proper reference of what is happening, but they need to be comfortable performing. Right. So the stage fill mix would be speakers on the side of the stage, just producing some of the sound so that people can hear. Now you can't have too much of that going on, because if you crank it up too much, you're going to have something that's called a feedback. The feedback is the sound that the microphone is picking up from the speakers that the microphone is producing. So the microphone is producing the sound, the speakers are reproducing the sound, and that's being fed back into the microphone. You're creating a feedback loop that goes into infinity, and it sounds like a really loud squeal kind of a noise. So that's as far as that. Okay. Now, I have a picture of a tiny bit of a miniature mixing board, but the big ones, the big mixing boards, they work this pretty much the same. Some of them are more sophisticated, have more bells and whistles and toys built in, but the basic operation is pretty much this here, but it just has more. So this is just 2 microphone channels and maybe a couple of line level channels here. And that's it. Now the big mixing board will be just a bigger one. It would just have more channels. And they would have more of the main controls as well. So we're just going to go over some of that quickly. Here's the top part. I'm going to have magnification of that. So you see that we have the XLR inputs that would accommodate the microphone level signal. And over here, right away on this one here, you have something that's called a pad. Okay, PAD, pad. And the purpose of the pad is to reduce the signal volume coming right in the channel right away. Right? Sometimes, usually it's like by 20 dB, 20 decibels. Without going too much of a detail of what decibels are. Oh, my computer wants to update. You know what? Later. The decibels. Okay, when it comes to power of a signal, if you raise the power of the signal by 3 decibels, you're doubling the power. If you lowering the signal by 3 decibels, you're cutting the power of the signal by half. Right? So the pad that is there takes the signal down 20 dBs. 20 decibels. So you can just that should give you some sort of imagination of what of how much the signal is being brought down. Again, when it comes to the decibels, it's a reference scale, and I would encourage you to investigate that on your own, because in this course we're not going to talk about that. Right? Maybe in some other courses in telecommunications you will, but not in this one. But I'll just go and give you what decibels are. It's a reference scale. A decibel is a reference scale comparing to something else. It's a logarithmic scale. That's as far as I'm going to tell. But the thing you have to remember, when it comes to power of a signal, you raise it 3 dB, or 3 decibels, you're doubling the power. So if it's 100 watt power, you raise it 3 dB, you're going to have 200 watts. And then that 200 watts, if you raise it 3 dB, you're going to have 400 watts, and so on. It goes down the same way, right? So that's when it comes to power. Now, power is voltage times current, electrical signal, right? When it comes to displaying things on oscilloscope, you are not able to, usually you won't be able to display a power of a signal, but you're going to be able to display voltage. So with voltage is slightly different. When it comes to the voltage, you raise it 3 decibels, the voltage. In order to double voltage, you're going to raise not 3 decibels, but 6 decibels. You're going to have double the voltage. Or you lower the voltage 6 decibels, you're going to cut the voltage in half. Right? So voltage, it comes double 6 dBs, power, double 3 dBs, okay, 3 decibels. So here's the pad that just basically right away in the pad you can because in XLR form, in a balanced signal, you can have a microphone level, which is in the range of 1 millivolt peak to peak, or you can have a line level signal. Yes, you can have in XLR balanced signal coming out of a keyboard, right, through the direct box, which converts unbalanced into balanced signal. So you can transfer that over longer distances. All right, so pad takes care of that. And also you have a 1/4 inch jack here. Now mixing boards are supposed to be the most versatile things because you never know what instrument you're going to deal with, who comes with what, and what situations you're going to use it with. So the better the mixing board is, the more options it's going to have of what you can actually plug into it, right? So you can have 1/4 inch here, and you can 1/4 inch input here, or XLR, right? In this particular mixing board, it's mechanically solved that once you plug it into the quarter inch, it's mechanically disconnecting this XLR input here. Okay. Now, what else is in this here? Here are the mains out, main mix. Well, that would be mostly front of the house. This would be if you combine all the channels. And here's the main. Where's the main? Here's the main out. All the channels, you adjust the differences or the balance of the reference of the volumes, and you have the proper balance of all the instruments and microphones and whatnot, sound sources. All that is going to come, this mixing board is going to combine that thing into one main output. You also have a headphone output if you want, and sometimes people ask what the tape is. Well, we're going to go over that a little bit. There's a little bit of an EQ here, and that that refers to the main outputs. So you can still EQ that or equalize the low and the mid and the highs of how much. General rule is that try not to add try not to amplify the frequencies. Try to have a good mix, and then if you need something, you try to subtract the frequencies when it comes to it. That's the best way of doing the mixing boards, right? Quite often you can see some people would do it. You're just going to look like this here. So you're going to have lots of high lows, not too many mids, and lots of highs. And it's going to look like a smile, all right? Not a very professional way of doing that. However, sometimes when you need, right? But it's popularly called a disco smile, because there will be disco DJs would no matter where they go, they would equalize things that way, all right? So it's a funny way of calling it. It's called disco smile, all right? And here's the main volume control. So in each channel, you have a pad, you have an input you can plug in. Then you have the trim or gain, all right? That basically sets the volume of the signal. So if the signal is too hot, you take it down. If the signal is too weak, you bring it up. So you bring that signal to a comfortable, controllable level. Then each channel has a little bit of EQ, highs, mids, and lows. Or this one actually does only highs and lows. Then there's another knob here or control that can send this signal into the auxiliary output or a monitor. So here's the main, and somewhere there would be monitor send here for the monitors. So this is a small versatile mixer. Also, this one here is a little bit of section of that you can have effects applied to each individual channel. So if you want to color the way the sound is, make a little bit of an echo or maybe a little bit of reverb or something like that. If you need to, try not to go too crazy with that. Then this control knob takes care of that, of how much of the effect that you choose is going to go into each and individual channel. If you don't want it, just take it down. All right. And this is the volume control of this particular channel, the final one before it gets to the final mix. All right. So that's basically how this one works. Here is the magnification of the back side here, and sometimes, okay, see, it says unbalanced. Of course, it's a RCA type of jacks. They look like this, like those phono jacks, right? And tape in and tape out. The mixing boards were designed way before the MP3 players were in existence. So the recording devices would be tape recorders, okay, or tape players, or something that's kind of making its way. It's coming back as, I'm not sure, some sort of like a niche, sentimental niche when it comes to connoisseurs of music. The cassettes are coming back. All right. So that's what the tape means, right? So you go to a tape recorder or coming out from the tape. But over here, right now you can plug in MP3 player or any kind of other input, sound source that has unbalanced signal, and you can just plug it in here, right? So they still call it tape. All right, so I just explained this to you, how each individual channel works. This is the effect section. Of course, every little mixing board, big or small, you're going to have to read the manual, but the principles are the same as the oscilloscopes that we're going to work with. I hope that we still have some of the old oscilloscopes, the cathode ray tubes that the green line, which are in the most basic form. I would encourage you to at least once try to set things up on the old cathode ray tube oscilloscope, and everything else, the digital scopes, all the sophisticated scopes, are basically working on the same principles, but it's going to be easier for you to understand those scopes. When you're dealing with digital scopes, they just have more bells and whistles and they're more comfortable to use. But if you learn how to do it in the most basic form, the principles and idea of how it works just works the same. Right? So same as digital cameras and the old analog film cameras. And when it comes to bigger mixing boards, some of them analog ones, they look like this, right? They just have more channels. And they could have more available mixes to be sent out back to the stage box, or sometimes not using the stage box, using direct cables. But if you use more direct cables, it's going to become a mess, right? But it's possible. We have talked about this already. This is the digital mixing board. Now this here could be like that. This would be equivalent of so many channels that you can plug in, except those inputs right here, they would be in the stage box, and the stage box would just give you one Cat5e cable to plug into the mixing board here. And you have a small section of sliders here, but those sliders are assigned to channels. So the digital mixing board works pretty much almost the same as the analog board as far as manual control of the channels, except those channels, you don't need so many sliders here. This is a 48, I think it's a 48 channel mixing, no, 24. Some of them are 48, so it's even bigger. So if you can have like a 48 channel, you don't need all the 48 sliders, but digitally you can bring those channels on the screen, and the screen is going to be assigned to those sliders. So you can say, okay, now I'm going to control channels from 24 to so on, and those are going to be brought to the screen, and automatically, kaboom, those things are going to just in a snapshot, they're going to go back to the adjustments that you left mechanically, and then you can do the adjustments and you can color up the different sections. So that's basically more compact here. That's how things are being done. When it comes to effects, and usually the effects would be vocal effects, or there could be compressors, there could be limiters, there could be EQs or feedback destroyers. There were delays, so the effects are many, right? There's for sure there's not enough time for me to go over each and every, because that would be if you're really interested in this type of work when it comes to mixing boards and sound and audio and all that, stage productions, maybe you could investigate our music industry art in our college. It's called MII, Music Industry Arts. Okay? As far as I know, I'm not going to mention any names because I'm not sure who is the coordinator at this point right now. I think Mr. Danny Broadbeck was at one point. Maybe he still is. Okay. If Mr. Broadbeck, if you hear me, I do the Zoom wave to you. I salute you. Okay. All right. So now, different ways of adjusting dealing with stage productions is you have all the control equipment, the amplifiers, and all the meat and potatoes as far as the control devices are being put on stage. And instead of running the Cat5e cable, you can do things wirelessly, either through Bluetooth or other wireless communication. So you just have the control consoles at the front of the house, and you don't have all the messy wiring right now between the front of the house mix and the stage, which is quite convenient, right? Now, I'm going to go over some of the microphones. I'm going to make a bold statement that this here, what you're looking at right now, I think this microphone, if I remember correctly, was invented or released first on the market in something like 1967 or something like that, but don't quote me on that, but it should be something around that. And up to date, still, this is 2022. This is the best by far vocal microphone, best in the world, right? Now, some people might agree with me and some people might not agree with me, but as far as I know, when it comes to audio productions, there are two camps. The world, the planet, is divided into two kinds of people. The first half is that they think that this SM58 by Shure is the best microphone ever, and there will not be any better after that. I am one of those, okay? And there's the other half. Let's say, no, there are some better mics. Yeah, okay, maybe, yeah, sure, okay. But, well, if you go into this kind of industry, you're going to make up your own mind. But I would encourage you to at least, even people who don't think that these are the best microphones in the world, they know these mics. All right. So it's for vocal SM58, Shure SM58, and you can click here on this link to have more information about that. Now. By Shure, right? Now, here are I would encourage you to listen to this in your headphones when you click, when you download the PDF form, you can click, this is a link right here, this picture is a link to the sort of A and B or A and B, C and D comparison between different brands of microphones. And you can see here, Shure SM58 is one of them there, right? So go ahead and later on watch this YouTube video by whoever it was. The reference is right there. Right? Now, balance or unbalance. We talked about that. The microphone, because it's a low-level signal, it needs to be balanced when it's being sent over maybe 100 feet distance. In order to be quiet enough. And as I said, one of these days, before we end the term, I'm going to bring, because I own a couple of those mics, I'm going to bring them to the class, and we're going to connect it to oscilloscope just to show how the signal is being presented from the microphone in the balanced way. Okay, so now. There's also a link here. Where's that link? Balance on unbalanced signal. Oh yeah, here it is. Here's this link. All right, you gotta watch this link because I'm going to ask some questions on the test here. The difference between SM58, SM57, and SM7B. Right? These are the basic form microphones. One of them is being used, like SM58 is being used for a stage vocals. Right? SM57 is the best microphone to use for stage instruments like a guitar, or sometimes it's a common practice, instead of connecting the guitar straight to the mixing board, people have their own stage amplifiers, stage amplifiers, like guitar amplifiers that have speakers on them. You just place this microphone in front of the speaker of the amplifier. It's a very common practice as well. Instruments, SM57, vocals, SM58. Now SM7B, this would be a studio vocals mic. So now, if you watch that link, you're going to be able to tell the difference between how they operate and how they sound, and you're going to know a little bit about how and why when it comes to this type of stuff. And I'm going to ask you some questions on the test when it comes to this. So please do watch. Look, this is just 7 minutes video here, right? Now here is as I said, this link here shows a little other video of comparing different brands of how they reproduce sound. Okay, balanced and unbalanced, we already done that. Now here here is a kind of conceptual diagram of typical sound system of what? Excuse me. Anybody would have any idea of what type of a sound system would this be? You can pipe in on voice, or you can just use the chat lines if you want.
Would it be like a home studio?
A studio? Close, but no.
School or something? I don't know.
School? Close, but no. All right. There's one, if you read the text that is on the picture, you'll be able to clue in quite quickly. But you just have to find that one word that would just show you what type of a sound system this would be.
Oh, DVD player.
Hey?
Or a DVD player or like a digital recorder?
Okay. Thank you for being brave and speaking out. All right. But I'll
Is
tell
it
you
like
what.
a choir performance?
Choir performance. So yeah, that's good. That you're looking at the right word. All right. Well, here I'm going to explain. Choir mics. Well, this would be a typical setup, well, kind of a basic setup for a basic system for a church sound system. Right? So you have the choir mics should be the giveaway a little bit here, right? Now this would be the microphones, microphone jacks on the walls or in the podium or lectern. And these here are something that's called, something I haven't mentioned, the difference between the dynamic microphone and a condenser microphone. Condenser used to be what people used to call a long time ago a capacitor, right? A condenser is a capacitor, right? But when it comes to microphone, the name stuck as condenser microphone. Basically what it is, it has two plates. It has two plates in proximity to each other, right? And as you speak, the plates are going to vibrate. And that means the capacitor that's made out of those two plates is going to change its capacity. And when it changes the capacity, it changes the resonating frequency, and there are some certain electronic circuits that are going to sense that change of capacity. Excuse me. Oh, wow. Talking a lot. And they're going to transfer that into electronic signal that represents the sound. Those condenser microphones are the cleanest microphones, however, and they are good for speeches, right? The only thing is that you can't have your mouth too close to that, because if you do the P, you're going to make those plates touch each other, and you're going to hear that boom, right? So they are basically they should be maybe like a basketball or volleyball distance from your mouth, and that's the best way of doing of using those mics. And those mics are supposed to be powered. Okay, so in order for that microphone to work, it has to receive a power through its cable that is connected, because it has some electronic circuitry to operate that mic, and that is called a phantom power. So when you see on the mixing boards, you're going to see a button somewhere along there, in different spots, but it's going to say phantom or a phantom power. It's a 48 volts DC, usually 48 volts DC. DC is being sent to that microphone. Okay, so that's the difference between these condenser mics and the dynamic mics that they do not need to use power. They just stand on their own, and they provide the signal. So the SM58, the Shure mics, the stage vocal mics, they are dynamic microphones. They do not need power. Now they are designed in such a way that even if the phantom power, because the phantom power, where's my mixing board magnification? Yeah, come on. Right here, right? The phantom power is going to be supplied onto a couple of the prongs. I forgot which ones they are. On here, Okay? So if you take a voltmeter, you're going to find 48 volts DC on that if the phantom power is on. So what happens if you plug in a dynamic microphone to it? Is that going to damage it? No, it's not going to damage it. The microphones are designed, the dynamic microphones are designed to ignore the phantom power. Okay? All right, so let's just go back to the my mouse. Okay, here. All right, so we have those condenser mics, and these are the best. We have a couple of wireless mic packs, and those receivers, the wireless receivers, are usually somewhere close to the mixing board. They're, as the technology advances, the wireless microphones are becoming more and more efficient, quiet. Excuse me. And sometimes, quite often, those microphones that I'm wearing, those lapel mics, lapel mic. This is a dynamic microphone, but the lapel mics also come in condenser version as well. The condenser microphones are more quiet as far as noise, and they reproduce the sound way better than the dynamic microphones. Okay. Now, whatever we have here, okay, so out of that one here, out of this mixing board, we have something that's called 70 volt amplifier. This is the lab, not the next lab we will be dealing with, all right? Now, the signal is getting, the mix is getting out of there and it's being fed into the 70 volt amp. And over here, we have the distributed audio, the one we were talking about with the speakers, with the step up transformer and step down transformers through the volume controls, and they're being distributed somewhere else. It could be to a different room in the church. It could be one speaker could be installed in the foyer, or which is the kind of the main lobby as you walk in, or some of the speakers can be installed in the something that's called crying rooms, right? The purpose of the crying room is that if there's a crying baby during the service of the church, then you can't tell babies to be quiet. They just cry whenever they want, right? And so it kind of makes it hard for the service to continue that way. Although sometimes people just keep going. But that gives the mom a chance to kind of step outside and go to the crying room, and the crying rooms usually are behind the glass, so the mom can see the whole thing, pretty much participate. It's just acoustically, different room, and so the mother can hear, or the parent can hear whatever happens. So those speakers also would be installed there, and there will be a volume control there as well, right? And of course, there's something that's called a little bit of an EQ here, and something that's called the front of the house, which would be the main speakers, and maybe some that's called so-called stage monitors as well. Right. So that's in a nutshell as far as I'm giving you when it comes to dealing with sound systems. All this stuff, all three sessions, PA system 1, PA system 2, and PA systems, this one, 2.5. It's, trust me, it's a drop in the sea, okay, as far as the information that I just gave you right now. But it's a good start, right? Now, we have a couple minutes left. Excuse me, just got something stuck in my throat there. I'm just going to give you a little bit of an overview of what you're going to expect in the lab number 2, and that's going to be just a one lab session. Okay. All right. What we're going to have main feed from the amplifier, right? And that is it's just hanging right in the middle of our countertops. We're going to pull wire. Here is our countertop with the computers and all these workstations, and there are chairs on this side, there are chairs on the other side. Here's the teacher's desk. All right. Now we're going to put a box of wire on the teacher's desk, and we're going to pull the wire all the way to the back. Excuse me. So once we pull the wire all the way to the back, we're not going to cut the wire yet. Right? We're going to basically mount it somewhere, physically prevent from being pulled back. And we're going to strip the wires and going to blind it with the wire nuts, so the two ends of that don't become shorted by accident. Right? Now, every single one of you is going to pull a little bit of a slack here, slack here. So right here, just like that. We're going to keep going from the back. As soon as you pull a bit of a slack, the wire is going to come out. Pull the slack, and we're going to work our way backwards towards the front. Right? When every single person has their slacks pulled here, we're going to interrupt the slack. Right? We're going to cut that. And we're going to cut it just so we can join it back together. But we're going to introduce one more wire here. So we are cutting it so we could tap in with another wire into it, and we're joining it right back together. So we are still having something, something like the main main cable going on, and we're going to have this kind of a situation here. All right, but we're just going to pull the wires, so we're cutting it just to join it back together and add one more cable, which means we're taking out the signal into the volume control. And I put a little bit of an EMT pipe on the desk, so that's going to simulate the pipe in the wall, right, the conduit in the wall. And that is going to be connected to a utility box, and the utility box is going to accommodate the volume control. Now, that wire that's coming out, and we're going to label those as we have mentioned that in the lab instructions. Okay, excuse me. So we're just basically we're making a pigtail here. We're going to connect all the blacks, all the reds, and if we have a shield, we're going to continue with the shield. So we're going to connect the shield as well. You can have it shielded or you can have it unshielded. Now, it's not going to affect the performance of the speakers. Shielded cable, sometimes you're going to be requested to put a shielded cable, so the signal that's being produced in the cable, it's not going to produce interference that could affect other equipment that's in the ceiling. Right? So then from that, we're going to run another wire, and we're going to bring that through this pipe. We're going to bring to the same spot, but these three are going to be connected, and this one is not going to be connected with those. Then we're going to prepare a speaker station with a transformer. We're going to connect a wire to that. One is going to go to common of the primary winding on the transformer, and the other one is going to go to the tap. We're going to show you. And then out of that, we're going to have a wire going into this spot right here. It's all going to be in the same spot, and that is going to be pigtailed as well. Right? Once you have all the pigtails done, you're going to bundle them up in one sort of a bundle, coil it up, and tuck it out. Right? It's going to be here. So it's going to be a pretend that we're in the ceiling. Right? Now, I also have the questions, and that's so here's the volume control. The signal that's coming out of the main line is going to be pigtailed or tapped into the main line, and it's going to be providing the signal to the input of the volume control. Out of the output of the volume control, it's going to come back to the same spot, and then it's going to be pigtailed to the wire that's coming out of the speaker. Now, people sometimes ask me questions, why can't we just connect the speaker straight into that? Yes, you could. There's a question, somebody came in late. Yes, you'll be able to watch that on YouTube. Just log into the YouTube playlist, all right? So some people sometimes ask, why can't we just connect the speaker right straight to that wire that's coming out of the volume control? Yes, you can. But here's the idea. I'm trying to give you the ways that are being to be implemented in the industry. Once you go and you have, let's say you have 200 speakers to install, you're going to have some sort of a structured way of performing your job, so it's efficient, time-wise, and well, actually time-wise, time is money, right? Plus, once you do it this way, it's serviceable later on because it's a structured way of doing it. This one here is going to look the same as the 37th one, and this 37th one is going to look the same as 57th one, all right? So there will be a service loop. So once you have that, so okay, so the way you do it, if it's in the hallway, right? If it's a long hallway, you're just going to put the box on the one side of the hallway. You're going to run in the ceiling all the way to the back. And then you're going to fasten the end of that somewhere so it doesn't run back when you pull it. And then you're going to pull the slacks wherever the speakers are going to be in the ceiling. So we're simulating the same environment here in our countertop in classroom, right? So one person can do that while the other person is preparing the speakers somewhere on the side, connecting the speakers and tapping them into the right tabs and making sure. So then you're going to have maybe 10 feet, 20 feet of a cable with each speaker. And then while that takes a long time, then the other person can still start preparing those pigtails here. So cutting it, stripping, and making sure and getting ready those pigtails right here that are going to the volume control if we're using a volume control, because sometimes we don't. Sometimes we just mount the speakers. We don't need volume control for every speaker if it's in the hallway. But if it's all bunch of speakers in the hallway and you just need that one in the office somewhere, then you're going to have to do it that way, right? So we're just going to do it that way for every speaker, right? And then once all those pigtails are prepared, then the two of you can go grab a ladder and just connect those speakers, coil the loop, tuck it in the ceiling, and that 10 or 20 feet of wire is going to let you put the speaker anywhere. It's going to give you the freedom of placing it anywhere in the ceiling tiles that they need to be. And if you need to change it, you just take it out and put it in a different tile. Right? So that's basically the way we're going to perform the lab. And we're going to walk around and give you pointers, suggestions, and possibly some corrections. All right, I'm going to give you, okay, you can close that in one word. We're going to give you some guidance when it comes to that. All right, cool. So that's pretty much it. All the other stuff that you're going to get in the in class, you're going to get the hands-on experience with that. This is a very popular system. Now, okay, once is okay. There's one more thing, right? When it comes to tapping, right? The step-down transformers on the speakers, they have taps. Again, what does it mean? The low side of the transformer, the low impedance is 8 ohms. It's connected to the speaker that has 8 ohms impedance, and that's permanently connected. That's it. On the other side of the transformer, you're going to have taps. There's going to be one common. So yeah, that goes to the one side always. That goes to the one usually will be the negative part of the or the ground part or the common part of the main line. And you're going to have wire pulled out of the transformer at different points, depending on which point you connect, and you connect only one point of the transformer. Depending on which tap you use more of the winding or less of the winding on the primary, which is going to tell the amplifier how much. Okay, it's going to not tell the amplifier. It's going to drain, depending on which tap you have, it's going to drain so much power to the speakers. So Some taps are going to make the speaker sound louder. Some taps are going to make the speaker sound quieter, not as loud. All right, now, so if there is a tap that says 1 watt or 1.25 or something like that, it's considered 1 watt, right? Or 2 or 1/4 of watt, or maybe 4 watts or so, or 6 watts or something like that, eh? Which means that if that speaker is tapped into this 1 watt tap, if the volume, if the main amplifier is running at the full volume, it is going to grab 1 watt out of that. Right? So here's the thing. Here's the thing. If this is a 100-watt amplifier supplying the power to the whole system, and we have all the speakers tapped at 1 watt, and this is a 100-watt amplifier, how many speakers can we tap into the whole system before we run out of power? Any answers? Speakers are tapped at 1 watt, and it's a 100-watt amplifier. How many speakers can we tap into this system before we run out of power? Speak out or send me at the go on chat line. Anybody? 100. There we go. All right, winner, ganyo. All right, Tanner, thank you. All right, 100 watts. All right, now if we tap the speakers at 2 watts each, and this is a 100-watt amplifier, how many speakers are going to be able to plug into the whole system before we run out of power? 50. There we go. Right. So another advantage of using that distributed audio system is that basically you calculate. We just look at what the power capability of the amplifier is, and you just add the taps. Make sure you don't go over. Right. And when it comes to this, it's a good idea to have the amplifier a little bit stronger than the whole system is going to be, because you don't need to use all the power, but you're going to have some reserve. When it comes to a stage gear, it's a different kind of rules apply. If you have a 100-watt amplifier per channel, so you have 100 channel, 100. So let's just take one channel of the amplifier. The one channel is able to is rated for 100 watts. What kind of speakers would you choose? Or if you have a 100-watt speaker of capable of providing 100 watts, what kind of amplifier power do you need to power it? What's the best scenario? Bigger, smaller, or exactly the same? Match it. Right? Without going for too long, I'm going to say match the power. Right? There's a temptation to say bigger, but not necessarily. Right? With bigger amplifier, if you're not careful, you're going to damage the speaker. Plus, if it's a bigger amplifier, that speaker, it's going to start working too hard, and yeah, it's going to get damaged. Right? If it's a smaller amplifier, here's the other thing. If this is a 100-watt speaker, and you're just going to put 10-watt amplifier, is that okay? Still not okay. It's because once you have you can crank the amplifier full blast to the point that it's going to start distorting. And if you study things a little bit further, distortion is basically almost coming close to a DC signal. Right? If you apply DC signal to a coil, it is going to not be very good situation for a coil. Coils are going to provide very low resistance to DC, and they can burn out. Right? So you can burn out a 100-watt speaker with a 10-watt amplifier. Right? The best thing is to match 1 for 1. It's the best scenario. So you get the full advantage of the amplifier providing the power, the speaker is receiving the power. If something is wrong, you're going to hear it. all right, in the speaker. Okay. No, it's okay. That's a good question. Well, you know what? I'm going send me an email, okay, and I'll send you an email back. I'll tell you which section. Now I'm going to later on today or maybe Friday, maybe tomorrow. The sections are pretty much crystallizing right now, so now I'm going to be able to split the sections into section 1A and 1B, 2A, 2B, and so on, and I'll give you the schedule on when is your next lab. Again, tomorrow, no lab. This week, there's no in-person lab. Just do the labs, the lab at home, according to the instructions that I already gave you maybe like 17 times by now. All right. Cool. Yeah. Just Leonard, just send me an email here. Right. Okay. We are coming up to the 12 noon, which is pretty much the end of this class. Any questions? Comments? If not, that's great. Of course, you can always send me an email if you need some clarification, anything. Okay, thank you. It was a good class. Let's see here. Okay, people are leaving. Thank you and goodbye. Oh, there's a question here. Stephen. All right. How exactly can that damage the speaker? You mean what? If you have a 10-watt amplifier and and 100-watt speaker, yeah, okay. So the weak amplifier is you can crank it up and it's not going to sound to your ear sometimes that is too loud, because it won't be too loud, but the signal might be distorted. And what signal is distorted is so here's a signal that is not distorted. Okay, now signal that is distorted is like this. Here it's just almost like becoming like that, or sometimes it's going to go as far as almost becoming DC signal, almost pure DC, close to a pure DC signal. You're sending a DC signal to a coil because the speakers have coils, and the coil is going to conduct too much current, because the DC current to a coil is almost the coils are going to conduct a DC type of a signal, just like a 0-ohm resistor. It's just going to pass through, which means it's going to pass through a lot of current through the coil that it's not supposed to, and that can warm up too much, heat up too much, and burn out. So that's so it doesn't take much, right, to burn the speaker coil, and it's not going to be by ripping the membrane out of the frame, but it's going to burn out the coil. And also sometimes if you put too much DC signal through a coil, the coil, there's a possibility of the coil of becoming like an egg shape by the forces of things, and that is going to rub against the cylinder and also can get damaged physically when it comes to applying a DC signal onto a coil. And you don't have to supply too much of it in order to damage the coil. Right? That's cool. All right, guys, I'll see you when I see you next week. Have a good one.